All right, everybody, as promised, here is the video for you to be able to go back and watch kind of how I estimate a square root without using a calculator per se, why you need to learn it, and just a kind of quick refresher from today's lesson. So for starters, the state test a lot of times will ask you to estimate a square root to the nearest tenth, meaning the first digit after the decimal point, kind of without using a calculator. Now, they'll give you a calculator to kind of do some multiplying, but they'll disable the square root feature. So you're going to need to know this for that very reason. Like, we got to make sure that we can, understand the process here. And again, with anything in math, another reason, you want to know, like, why you're learning something. Well, this is all about just, following a step-by-step process, evaluating how it went, how to make adjustments moving forward. So that's why you want to learn this in addition to it's just something that we, need to teach you. So let's pick it up. We were on slide 6 today. That's kind of where we started. And today, the question is estimate the square root of 83 to the nearest 10th. The first thing to do is figure out what integer it's the closest to. And again, the best way to do that is if you don't have all your perfect squares memorized, is to go back into the chart. Okay, so you find these are the integers down here. When they say the nearest integer, that's what they're talking about down here. What we want to pay attention to is where does the square root of 83 fall? Well, the square root of 83 falls between 81 and 100. So what I know is this about the square root of 83. I know on a number line, it falls between 9 and 10. Is it closer to 9? Is it closer to 10? Well, that's how you use what you know about this to figure that out. So, through just some basic subtraction, I don't think you need to see it, but I'll show it to you. 83 minus 81 is a difference of 2, and 100 minus 81 is a difference of 19. So which of the two integers is the square root of 83 closest to? Well, it's closest to 9 because the difference between the square root of 83 and the square root of 81 is much, much closer than the square root of 100 to 81, okay? So that's the start of it. So I know that it is closer to the square root of 81, or 9, than it is to 100, or the square root of 100, or 10. Okay, now, test the intervals close to 9. Start with the interval between 9 and 9.1. So since we're trying to estimate to the nearest 10th, I'm going to start at 9, which could also be rewritten as 9.0, okay, and 9.1. Then what I'm going to do is I'm going to square everything, right? I'm going to take 9 and I'm going to square it, and 9 times 9 is 81. That I know. And 9.1 squared, I'm going to use a calculator to make sure I get it right. 9.1, and I'm going to square it. And that is 82.81. Okay, so now I have to ask myself this. Is this inequality true? Is 81 less than 83 and 83 less than 82.81? Thanks for pausing to think with me. Heck no, it's not. 83 is bigger, so this inequality isn't true, which means that if I was to plot this on a number line, evaluate it, the square root of 83 does not fall between 9 and 9.1. So now I'm going to check a second interval. To make it easy, just go up 1 instead of 9.0 and 9.1. Now look at 9.1 and 9.2. Okay, same thing, squaring. Now on this one, I know that 9.1 squared, I've already done that over here. So I already know that. That's 82.81. What I need to find is what is 9.2 squared. So again, come over here, evaluate it. 9.2 squared is 84.64. Okay, now I'm going to enter that. 84.64. Now, is this inequality true? Does this make sense? Does it work? Is 82.81 less than 83? Yep. And is 83 less than 84.61? You bet your sweet bippy, it definitely is. But now you have to figure out what the estimate is. What is the one that is closest to? Well, here's how that works. You know that the square root of 83 is between 9.1 and 9.2. You have to figure out which one of these two numbers 83 is closer to. So again, come back here. You're going to go and subtract 83 minus 82.81. And I did it that way because you always subtract the smaller number. Don't. Okay. Then I'm going to do 83. I'm sorry, not 83. I'm going to do right over here 84.64 minus 83. And that gives me 1.64. So, is 83 closer to 82.81 or 84.64? Well, you could see here, because this difference is 0.19 and this difference is 1.64, that the square root of 83 is much, much closer to 82.81 than it is 84.64. So that means that since it is closer to 82.81 than it is to 84.64, that the square root of 83 is approximately 9.1. Okay? So again, it's just about testing the intervals here, and that's how I did that. Now, to get you started on slide number 7, okay, you're going to estimate the square root of 106 to the nearest 10th. So again, what two perfect squares does this fall between? Does it fall between, where is it? So 106, I see it falls between 100 and 121. So the square root of 106 is going to be somewhere between 10 and 11 on a number line. So I know that 100 is the smallest square root, closest to 106, and 121 is the largest square root, around 106. Now, I know that the square root of 100 is 10. All right. So now I have to test the first interval. So again, same thing here. One thing to think about as you're getting ready to test intervals, right? Is 106 closer to 100 or 121? Because the reason you want to think about that is if this number is closer to the second number, you're probably going to want to test something 0.5 or higher. If this is closer to this number, you're going to want to test something between 0.0 and 0.4, okay? So since 106 is way closer to 100, the first interval you probably would want to check would be 10 and 10.1, okay? Now, just like on this example, the next thing I'm going to do is square everything. So I'm going to do 10 squared. Now, a lot of people want to know, wait a second, how do you get the little exponent next to the number? I'm going to show you. I typed in my 10, and you can click Format, Text, let's go here to Superscript. And that'll raise that to squared. And then this one will be 10.1. And again, I'll square it, the superscript of 2. And this is where I'm going to leave you, because I want you to try to do this practice problem yourself, and we'll review it tomorrow. But I will tell you this. Everything you're doing on slide 7, we've already done on slide 6. You just have to repeat these processes. And yes, that's a word, processes. You need to complete these processes on this one. The only difference is you're going to be dealing with numbers like 10 and 10.1 or a different interval over here to figure out how close 106 is to its, number to the nearest 10th. So hopefully this makes sense. I definitely think it's easier to probably watch this video a couple times before you finish slide 7, okay? Don't worry. Do your best to get caught up and then attempt to do this one. I want it done, but we'll go over the correct answers tomorrow, okay? So, thank you. Have a wonderful evening, and I'll see you tomorrow during math class. Have a great day.